This is section 11.7. In this section, we are going to learn about events involving the word and we'll also cover conditional probability. To start with, we're looking at and probabilities with independent events. And it states, if A and B are independent events, then the probability of A and B can be found by finding the probability of A times the probability of B. For this slide, the picture in the margin shows a family that had 9 girls in a row. Find the probability of this occurrence. All right, so we need to find the probability of having 9 females in a row. So what we need to look at first is, what is the probability of having a female? Being that we have male and female, the probability is 1/2 for a birth of a female. So the probability of having 9 females, now each birth is unique. One birth does not influence the outcome of another birth, so therefore they're called independent events. Each birth is an independent event. So what we would have is, for the first birth, we would have 1/2. Second birth is 1/2. Third birth, and I'm going to keep writing these out until we have 9. And right now I just have 5. And here we go with our last one. So this is the same as, a little easier to write it would have been just to put 1/2 raised to the 9th power. And if we place that in our calculator, if you want to multiply it out by hand, you should get 1/512. So the probability of having 9 female births in a row is 1/512. If the probability that South Florida will be hit by a hurricane in any single year is 5/19, what is the probability that South Florida will be hit by a hurricane in 3 consecutive years? All right, so we do know that we're looking for the probability of 3 consecutive years. They already gave us probability of a hurricane occurring. So each year is independent of the other year. So this will give us, my first year probability is 5/19. My second year is 5/19. And my third year is 5/19. Or you can say 5/19 to the 3rd power. And the calculation for this should give us 125 divided by 6,859. So this would be the probability of South Florida having a hurricane for 3 consecutive years. Okay. That would conclude the answer for part A. Part B is asking us, what is the probability that South Florida will not be hit by a hurricane in the next 10 years? All right, in the next 10 years. So probability, no hurricane, the next 10 years. All right, so first of all, we need to find the probability of no hurricane. And this can be found by taking 1 minus the probability of a hurricane. So I have 1 minus 5/19. which will give me 14/19. The probability of no hurricane in South Florida. So when I revert back to my original probability of no hurricane for the next 10 years, I'm going to use the 4/19 as no hurricane, raised to the 10th power for the next 10 years. And we should come up with 0.047, so 47 thousandths. So we were just introduced to and probabilities with independent events, and now we're going to learn about and probabilities with dependent events. All right, so this one says if A and B are dependent events, then we have the probability of A and B is equal to the probability of A times the probability of B given that A has occurred. All right, so A has to occur first, and then we take the probability of B. This problem demonstrates and probabilities with dependent events. So 3 people are randomly selected, 1 person at a time, from 5 freshmen, 2 sophomores, and 4 juniors. Find the probability that the first 2 people selected are freshmen and the third is a junior. All right, so what I have so far is 5 freshmen. I like to write out what's given in my reading. 2 sophomores, and 4 juniors. And that's going to give you a total of 11 people. If you were to add this together, we're starting with 11 students. Then we want to break this down into, you have your first pick, and we need it to be a freshman. And then we have our pick number 2, which is also a freshman. And then our third pick, which we want it to be a junior. All right, so let's think about this. On this first pick, we have a total of 5 freshmen out of 11 people. So we have 5 11s. Right, so we selected 1 freshman for that first pick. So that means on our second pick of a freshman, we only have 4 freshmen to choose from. And now we've also decreased the number of people we have available, which is 10. All right, for our third pick, we want a junior, where we have exactly all 4 juniors available to select from. But because we've already selected 2 people for the first and second pick, we now only have 9 people remaining to choose from. All right, and because these are dependent events, we will be multiplying. This will give you 8/99. So 8/99 will be the probability of selecting the first 2 selections to be freshmen and the third to be a junior. Our final concept for this section is conditional probability. And it states the probability of event B, assuming that event A has already occurred, is called the conditional probability of B given A. All right, and it says this probability is denoted by this symbology right here. The probability of B has a vertical line A. This vertical line means given. We would say given that. So the way we would read this is the probability of B given that A has occurred. Let's review this problem. A letter is randomly selected from the letters of the English alphabet. Find the probability of selecting a vowel given that the outcome is a letter that precedes H. All right, so the condition part is that the outcome is a letter that precedes H, gives us this sample space right here with the letters A, B, C, D, E, F, G. These are the letters that precede H. Notice that there are 7 letters here, and that has to occur before we can say selecting a vowel. So we're looking for the probability of a vowel given that the letter precedes H. So that's our probability. Remember, that's the given that. So we've met the condition of given that precedes H with this right here, sample space if you want to call it that, or our set. The vowels in there are A and E. So we have 2 vowels out of the 7, which gives me 2/7 would be the probability of having a vowel given that the letter precedes H. So 2/7 is our result. For our final problem here, it states that you are dealt 1 card from a 52 card deck. Find the probability of getting a heart given that the card you were dealt is red. All right, so the first thing we need to think about is that given part, given that you're dealt a red card. So there are 26 red cards in a deck of cards. And these red cards are made up of hearts and diamonds. These are the suits, hearts and diamonds. Right, so of those red cards, 13 hearts are red. All right, so let's look at that first probability. Find the probability of getting a heart. The probability of a heart, given that, there's my vertical line, given that you were dealt a red card. Given that you have a red card. So your limitation on here is that you have a red card. So think of that as your denominator. We just said we have 26 red cards. And the probability of you getting a heart, well, there are 13 hearts. And we reduce this. And we have a 1/2 probability that if we are dealt a red card, that it will be a heart. Right, for the second probability, it says find the probability of getting a red card given that the card you were dealt is a heart. So the probability of a red card given that you were dealt a heart. And this one's kind of a no-brainer, but let's show the work. We have given a heart, so we have a total of 13 hearts in the deck of cards. And then for it to be a red card, all 13 would have to be red. So we have a probability of 1, which means that it's 100% likely, and it will occur, that you will get a red card given that you were dealt a heart.